All right, guys, go ahead and put your name at the top. Put what period you're in, so if it falls out of your journal, we can get it. Go ahead and fold it in half. And we're going to get this in our journal. I was missing this. I needed to write that down. Level 2. And I'm not sure what page we're on. So I'm on page 29. So I'm going to put that back in my table of contents. Okay, you might be on a different page. Just go to your next blank page. Okay, and then we're going to start filling this all in. Some important things to know. You need to know what a quadratic is. A quadratic is simply this form. So it has an x squared, an x, and a number. It's a quadratic. That's it. So 3 terms at most. And the highest power can be an x squared. A binomial, think of it like a bicycle has 2 wheels. Just has 2 terms. Now factor, we've been doing factor trees. A factor is simply either a number or an algebraic expression that divides another number or expression evenly. It's really important you understand that there's no remainder left. So here, we're learning how to factor this. This is called a difference of squares. You're going to have to start recognizing this. First, we're going to look and see if we can GCF. We can't. So next, we're going to set up our big X. Now, it's going to be big. It's going to be, we're getting our numbers from here. So it's A times C and B on the top. So for us, the number at the end goes here. And there's no middle term because there's no, I've got an n squared, but I don't have anything that's just an n. So it's a 0. Now, to find our factors, we need them to add to B and multiply to A times C. So these 2 numbers are going to be your factors. So you're going to draw an arrow right here to remind yourself. These are going to be your factors. So the only way to multiply to 25 is 5 and 5. Now since it's negative, one of these has to be negative. So that these multiply to negative 25 and they add to 0. Then we set up our parentheses. Now you're going to want to make these pretty fat because it's got to fit in whatever your letter is, and this is one of your factors, whatever your letter is, and the other factor. And then we just set each of these equal to 0. Now there's a lot of ways they can ask this question. They can ask you what's the factor, what's the root, what's the solution, what's the x-intercept. There's a lot of ways they can ask the same question. They ask for the factored form, that's your factored form. If they ask for the root, you're going to have 2. If it asks for the solution, that's your 2. If it asks for the x-intercept, that's your 2. A lot of vocabulary that means the same thing. I'm going to go through it again. The negative 36 goes on the bottom. There's no middle term. 36, the only thing that we could do 4 and 9, we could do 6 and 6, we could do 3 and 12. We have to do 6 and 6 because we need it to add to 0. So I'm going to have 1 be a negative 6 and 1 be a positive 6. Now the order of this doesn't matter. You could do the negative first, or you can do the negative second. Doesn't matter. Set each part equal to 0. That's it. This is still a difference of squares, but we've got to do a GCF first. So GCF, we're just going to take out what's in common with both of those. So you can just use your calculator. And I always try to see if I can take whatever the front coefficient is, if I can take it out of everything. So I would do 288 divided by 8 is 36. So this is already, we've got the 8 factored out. Now we just like normal. 6 and negative 6. Set each part equal to 0. Now the 8 can't equal 0, and there's no variable there. So the 8 is not helping us. We don't need it. So we're going to take each part of this. That's it. We're going to GCF here. We can take a 3 out of both of those. What multiplies to negative 25 and adds to 0? Negative 5, positive 5. So then we just have... So this is your factored form. And then if they want the roots or the zeros or the solution, you set each part equal to 0. And you solve. And now we're getting into the meat of the class. This is one of the basic things that they're going to expect you to be able to do. So let's break it down together. Remember that this is your b, this is a times c, and it goes ax squared plus bx plus c. So the negative 7 goes on the top. This is just a 1. For today, this is going to be a 1 for your class, unless you can factor it out. So we're going to have 1 times 12. And we need things that multiply to 12 that could add to 7. So 2 and 6, there's no way those could add or subtract to 7. 3 and 4, that could work. We could get those to be 7. So we're going to use 3 and 4. Make both of them negative. Because a negative times a negative is a positive. And when you add two negatives, it's a negative, it stays negative. So we're going to have v minus 3. V minus 4. Now again, the order on these doesn't matter, and if it helps to see why it doesn't matter, think about multiplication. 3 times 2, 6. 2 times 3, 6. The order doesn't matter in multiplication. So set each part equal to 0. So this is your factored form, and then this is if they ask you to solve. That's it. Let's try this one. Oh, that shouldn't be there. My bad. That's a typo on my phone. Okay, we need two things that multiply to 14 and add to negative 9. Well, 14, I could use 1 and 14. That doesn't help us. I could use 2 and 7. Hey, those could add or subtract to 9. Make both of them negative, because that now adds to negative 9, multiplies to positive 14. This is your factored form. And then if we solve, and you're done. This one might look a little bit trickier. Many students struggle with what number to put here. Think of it as a 1. So it's a minus 1p. Now what multiplies to 6? I could use 1 and 6. I could use 2 and 3. Now I'm going to use 2 and 3. To multiply to negative 6, it wouldn't matter which one's negative, but to add to negative 1, the 3 has to be the negative, because this is the only way to add to the negative 1. So set up our factors, set each part equal to 0. Solve. Okay, go ahead and put the negative 20 at the bottom. Negative 1 here. I could use 2 and 10. Is there any way that's going to add or subtract to 1? No. What about 4 and 5? Yeah, that could work. 4 and 5. 5 is going to have to be negative so that it can add to the negative 1. So we've got x plus 4, x minus 5, and we set each part equal to 0. And solve. To be honest with you, I can usually jump from here to here, and I'm hoping you guys are getting to the point where we don't have to show every step. Got it. That's it.